So let's take this problem. I will use print screen. Where is my print screen? Here. And let's put it in a paint to have the picture for this particular problem. So our problem will be this one. We know all the aspects which we must to solve, and let's keep it somewhere in this part of the screen because it's easier to work later. So let's start ANSYS. Not here. So ANSYS Classic, because there is also a new, more difficult to be understand for beginners, ANSYS Workbench. It is very good, but I suppose that I have no more the path here. Control C. Control C. Let's put here Control V, and this is application number 28, right? It was not given. So first of all, we must draw in ANSYS this cross section. Of course, due to the double symmetry, we can take just a quarter. And after that, I will consider also the whole structure. So it is a good practice to draw first just a quarter, and then if necessary, I will use symmetry to build the complete structure or the complete cross-section in this case. But this is a general idea. If possible to draw a smaller part, you can do that, and after that you can use the symmetry to define all the problems. So let's change the background here, and you can use modeling here, and we have to generate just a quarter of this model. So I will draw, let's say, a quarter of this large diameter, and let's say, okay, let's create an area. The area is a circle. I will take a partial annulus, and here the origin is this one, so the inner radius is 0, I can omit 0, theta 1 is 0, I can omit, the outer radius is 40 because the diameter is given and it is 80, and the theta is 90 degree. So I will use apply, and I have this part here. Now I will remove here this circle. I can create just a quarter or even a complete. It's easier to create a complete circle. So the origin is here, and the radius of this one is 10 because the diameter is 20. So now I have the second circle, and I need more a circle here which have a new radius, which is 50. You can observe here the radius is 50, and or you must calculate, but I will check. I suppose that this radius is correct, but we don't know exactly right now the origin of this one. So I will define first a circle and that I will move it a little bit. So let's create a new circle with a new radius which is 50 in this position here. This is large. So the distance, let's plot some lines. The distance from this point to this point may be used to translate this last circle and to put it in the correct position. For that, we have here the distance from this point to this point as 15. The radius is 50, that means 65. So let's try to move. Let's solve for, let's save first, and let's use moving. Let's move this area. Because all two circles have the same area, the program see here two coincident centroids of area. I will take next. Okay. Okay again. And I want to translate this one 65 on X direction. And now I will check that the distance, let's check the geometry, k point distance, the distance from this point to this point must be 15. That's okay. Yeah. So let's save again. It's a good idea. And let's use operate boolean and let's use subtract area. Please note that here you have information. So pick or enter base area. The base area is this one. Apply. And then enter to be subtracted. This one and this one. And now I obtained a quarter of this geometry. This is the first step. You can save it. And let's make some more verification. Check geometry. In the program, we know this distance is okay. We know that from this point to this point is around of 16. Let's check that. The distance from this middle point to this one along y direction is 30.75 and here is 60. It's very close. Yeah, it's not exactly 60, but if this one is, yeah, so the geometry may be good. Sometimes when you work on a math paper, you can draw the geometry at scale and just you put the ruler and measure each coordinate if necessary. I will use the area to define a cross-section area. For that, it's not very simple for beginners. This is the reason why we use the octave first. In sections, we have cross-section for beams. Usually, if you remember from last week, we have some common cross-sections which can be defined particularly using some coordinates for this particular quadrilateral or for a rectangular B and H or for this particular annular cross-section inner and outer radius and so on. Z cross-section, a lot of parameters which must be given here, and I showed you last week. And here we have a general cross-section, but general means that you know the area, the second moment of area, and a lot of parameters here, and we don't know for that one. So it's not possible to use this one. So, and here you can see that it is possible to have a custom. And for that, we must write the cross-section from an area. So for more areas. In this case, we have just one. We can do that. We can start that right now. But generally, the program must know, okay, how the mesh will be. And in this case, you must put some information on lines to define the mesh. In ANSYS, because the results obtained with quadrilateral 8 elements, 8 noded elements, the results are good. ANSYS use only MOM in 8 if you want. And let's suppose that in meshing we can use size control and manual size for lines. And I will use picked lines. So let's suppose that this line will be divided in 2 or in 1. Let's put 2. As you can read here, number of element divided. Let's put 2. For this one, let's put, for example, 4. For this one, you can take, for example, 8 because this length is larger. Or maybe also, let's say, put 6. For this one, let's take, for example, 7 or. And for this one, let's put 5. It's arbitrary if you want. Okay. And now the program will know that the mesh will respect these boundaries. And you can use also section here, and you must write the cross section from this area. The program said, okay, line element may be specified. Please refer to ls side. We use that. Yeah. And I will take this area and okay. And now, as you can see, the mesh was done. Only quad elements here. And the program is waiting for a cross-section name. So let's put here sect28 because our program is 28. Now we have also the area, but I cannot see the information. And we must read the section mesh. For that, I will use, for example, the sect1. This is the first cross section. We must take the centroid, but I will take by default. And our cross section, which was saved, was 23 instead of 28. Yeah, it's not. It's in a different course. Was last week. So our directory is this one, lab 2, 28. Okay, and open. Yeah, okay. We don't see no more, but now it is possible to plot or list the section. Let's list the section. I have section number 1, and you can have a list in which you have the area, second moment of area, but these all correspond to the centroid. Better is to plot the cross section. Somewhere you must, this is for beam. Yeah, as you can see here, you can plot for the section. The section is, we have just one. Yeah, I want to see also the mesh. And the program gives us the area, second moment of area. This corresponds to the centroid. centroid is here, this small XOR, yeah, is the centroid, and more information which is not known for you in this moment, but area it's okay. Now the centroid you can see it here, and the coordinate on X and Y, yeah, this is 0 X axis, Y axis, yeah, and the most important values are this one. As you can see here, the cross product of area, this second moment of area here, is not 0 because we have not a symmetry in the model, right? And let's suppose that you want to have the results for the complete cross section. You can also plot again to see node numbering. Yeah, this is the node numbering, which will, you can also see the cell numbers or the element numbers, which was used internally to the program. The material is the same, but sometimes you can have a composite cross section from two different materials. Yeah, you can use color, or I don't know what means RST order. Let's check. I don't know. Okay. I don't know. We must read more. Yeah. Or generally, I can't. I'm not interested in see just the cross section, and you have the information. So I will save, and let's create the section number 2. The section number 2 will correspond to the complete area. So let's plot the area. As you can see, I changed the view. You can have a three-dimensional view. Let's take a 2D one. So let's use modeling, and let's use the reflect. So I will reflect area according to, so this area according to this normal of the plane. That means this is the plane, the normal of the plane, it's X. Okay, apply, and now again I will use reflect for all picol according to the normal of the plane Y, and directly I will use OK, because if I will use apply, the program will wait to a new reflect command. So OK, and let's use fit, and this is our complete cross section, which is built from 4 different areas. You can keep it as it is, or if necessary, you can add all the areas in a single area. Usually the areas are not connected, so it's a good idea to add them, or if not, if you will plot the lines, you will see that here is a common line. If I will use, for example, select here a line by pick, here the program see 2 coincident lines. Yeah, if I will use cancel here, and I will take, for example, this line here or this line here. Yeah, so coincident lines may give us some problems, so you can use adding of area. So I will use operate boolean, and let's add this 1, 2, 3, 4 areas. And now if you plot, you will see the lines. Some of lines was let's say have the number of division okay, some of them not. You can use again the element or line size. ls size is a command. You can also use ls size from this line if you know, and you must put the line number and the element, but easier is to work graphic user interface. Graphic user interface means that I will go back to the meshing, size control, manual size, lines, pick lines, and let's say this line and this line and this line and this line this time will be divided in not 8, not 10, let's put only 3, a number which is not so good. Yeah, this one, this one and this one, 4 lines here will be divided, let's say, in 2, and this line, this line, this line and this line, let's say, to be divided each in 2 again. So this is not a so good mesh. Yeah, maybe the first one. You can also use a very fine mesh if you want. Yeah, and now I have an area. I will go back to the section, beam cross section, right from area, click on this one. Okay, yeah, the mesh is maybe okay, not so good, but maybe. And this is section 28, let's say full. After that, I will read this cross section. The number of cross section will be 2. The program give us like section 2, or you can put here section full if you want. Not important. And here I will take the second one. I will load it, and now you can plot section 1 or 2. Let's plot 2, and let's show the mesh. So the mesh was defined, and here you have the numbers. As you can see, I have a middle node here. You can see also in the picture. So this value may be very close to the real one. If you want better results, you can improve the mesh. And for that, let's save. Let's go back. Let's plot the area. And let's use the meshing control for all lines. Let's plot the line. And now let's suppose that I want to have a line with the length equal with, let's say, 10 millimeters. Let's try. So first of all, I will clear the first pickle, the size which was defined, and I will define new division. I will pick all lines, and the size will be 10 or 5. Let's take 5. 5 is small enough. As you can see, with 5 I have something like that. You can try also for 2. It's finer mesh. Yeah, and let's write again this is the new mesh, and this is full and finer, or very fine mesh. And read number 3, let's say full and fine mesh, and I will load this last. And you can plot again the section 3, and if you will examine, let's say just the cross-section area, this is 2591.4. If I will plot the previous one, so let's take here. We have small variation, but not so important. Okay, but this is the correct answer for the problem for complete structure, not for just a quarter. Yeah, and if you take a look at this one, the cross product area here, or moment of inertia sometimes is called for a cross section area, but this one must be 0 due to the symmetry. It's not exactly 0, but it's 0 point around of 2. If you compare with this one, which is 10 at power 7, yeah, and again a large number here, this error is very small. If we take a look at very fine mesh here, this one is even smaller, 0.002, but no very important improved results are obtained here. So if you have time and if you want, you can use also ANSYS to solve this problem. I will stop the recording for this presentation and I'm waiting to answer to your